to do a review of yesterday's assignment, which was on phase diagrams. So the first part of this worksheet gives you a good little overview of most of the things we talked about yesterday. The one thing to add in, we talked about the triple point yesterday, is the critical point. I mentioned it, it wasn't specifically in the notes or the slides, is basically the point between a liquid and a gas. If you get above this critical point, the liquid and gas phases are indistinguishable from each other, and they are called a supercritical fluid at that point. So this does a little bit of review of what the triple point is, and then remember, standard pressure is 1 atmosphere, or 101.3 kPa, or 760 millimeters mercury. So here's the phase diagram that you'll be looking at for some of the questions, and it says, note that normal refers to at standard temperature and pressure. So standard temperature is 0 degrees Celsius, and standard pressure is, we'll use atmospheres because this graph is in atmospheres, is 1 atm. Then we're going to go down, so we want to know what the normal freezing point is of that substance. So at 1 atmosphere, when is the substance going to change from a solid to a liquid? So we can go to our 1 atmosphere line, follow that across, and that intersects at right about 100 degrees Celsius. So the freezing point is going to be 100 degrees Celsius, and then the melting point, which is a question later on, is also 100 degrees Celsius. Let's take a look at the normal boiling point. So that's at 1 atmosphere. We're going to go across to the point between the liquid and the gas phases, and that looks like it's right over 300, so let's call that about 325. And again, with some of these, unless they fall right on the line, you can kind of eyeball it. Maybe you said 350, that's okay as long as you kind of understand it. So then we're going to do some movement around. So we want to know what phase, solid, liquid, or gas, is a substance at 2 atmosphere and 100 degrees Celsius. So let's go to 2 atmospheres up here. 100 degrees Celsius. So that's going to put us right about here in this range. So that means we are solid, because it goes solid, liquid, and gas from left to right. So we're going to be a solid at that temperature and pressure. But now we're going to be staying at 100 degrees Celsius, but changing the pressure. So we're 100 degrees Celsius, but we are now at 0.75 for pressure. So if you go up, that's going to put you right in this little V region. So we're going to be a liquid at that pressure. So liquid there, and then we'll have a couple more just like that. So we want to know what phases are going to be at 1.5 atmospheres, 50 degrees Celsius. So let's go to 1.5 atmospheres. We're going to go to 50 degrees Celsius, so that puts us right about here. And it looks like we're a solid because we're right between that 0 and 100, so we're in the solid range. So we got a solid. And then we want to change it, so we are at 1.5 atmospheres, but now we're changing the temperature to 200 degrees Celsius. So we are, was it 1.5? So 1.5 atmospheres, we're here, but we're going to go all the way over to 200 degrees Celsius. So that puts us in that V range, so we're going to be a liquid. So we're a liquid there. Now we're going to do some more moving around. We want to know if the substance was at initial pressure of 1.25 atmospheres and a temperature of 300, and then we lower the pressure to 0.25 atmospheres, what phase transitions would occur. So 1.25 atmospheres, 300 Celsius, and then we'll lower the pressure. What was that again? 1.25. So 1.25 and 300 degrees Celsius, that puts us here. So we're in the liquid range, but now we're going to lower the pressure. So I'm going to go down, crossing this line, to 0.25 for the pressure. So this is the line between liquid and gas. So we're going to vaporize. So that would be the state change. We're changing to a gas. So vaporization. And last question is if you have a quantity that's 1.25 atmospheres, a temperature of 0, and then we lower the pressure. So 1.25 atmospheres and 0. Now we're going to lower the pressure to 0.25, but this line, this is the solid, this is the gas. So when we go across this line, we're going to go solid to gas, which is sublimation. That's what dry ice. That's what dry ice is. So sublimation. So here's a good review of yesterday's assignment. Make sure you take a look at the review sheet for today and work on that, which is today's assignment.